I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about Cayley-Hamilton theorem. So, Cayley-Hamilton theorem is nothing but every square matrix satisfies its own characteristic equation. In Cayley-Hamilton theorem, we are considering only the square matrix. So, square matrices are nothing but number of rows and columns are equal here. So, uses of Cayley-Hamilton theorems are here going to calculate the positive integral powers of square matrix and then to find the inverse of a square matrix A. These two are the main uses of Cayley-Hamilton theorem. So, now we are going to see one problem. So, here we are going to verify that given matrix A, this is 2 by 2 matrix. 1 to 2 minus 1 satisfies its own characteristic equation, and we are going to find its a power 4 and a inverse. So here the given matrix A is square matrix. Now we are going to check Cayley-Hamilton theorem, that means the square matrix, so whether it is satisfies its own characteristic equation or not. After that we are going to find its positive integral power a power 4 and its inverse a inverse. Here, the characteristic equation of 2 by 2 matrix is lambda square minus s1 lambda plus s2 equal to 0. Here, s1 is nothing but sum of main diagonal elements. So, here the sum of main diagonal elements, adding these two values, we get 0 here. Next, s2 is nothing but determinant of A. So, finding the determinant of A, we get 1 into minus 1, 2 2s are 4. So, minus 1 minus 4, we get minus 5 here. Now, the characteristic equation is substituting S1 value in this equation and the S2 values in this equation, we get the characteristic equation is lambda square minus 5 equal to 0. So, by Cayley-Hamilton theorem, instead of lambda, we replace it by square matrix A. We get a square minus 5i, which is equal to 0. Now we are going to verify whether this equation is satisfied or not. Now we are going to find the a square value. A square is nothing but multiplying a into a, we get a square here. So a matrix is 1 into 1, 2, 2 minus 1. So multiply a into a, we get the final value is 5, 0, 0, 5. So substituting a square value in this equation, a square minus 5i. So a square is 5005 and 5 into I is nothing but identity matrix, that is 1001. By simplification we get it will be 0. So coming to the conclusion, every square matrix satisfies its own characteristic equation. After the verification part, now we are moving into the find the a power 4 value. So consider a square minus 5y equal to 0, multiply by a square on, from this we have a square equal to 5y. Multiply by a square on both sides of this equation, we get a power 4 equal to a square into 5i. So a square matrix already we found 5005 and 5 into I means we get 5005. By multiplying these two matrices, we get a power 4 value is 25, 0, 0, 25. Next, we are moving into the its inverse part. Now we are going to find its A inverse. So here also we consider the equation a square minus 5y equal to 0. Multiply by A inverse, we get a square into A inverse, we get A 5 into I into A inverse means we get 5 into A inverse, so which is equal to 0. So by interchanging values we get 5 into A inverse is equal to A. Here the A inverse value is equal to 1 by 5 into A. So finally A inverse value is equal to 1 by 5 into A value is 1 to 2 minus 1. So coming to the applications of Cayley-Hamilton theorem in engineering field, in control system engineering, it is very much. It is useful in studying system stability and controllability. In electrical and electronic engineering, first of all we find the powers of given matrix. It is used to solve network equations. Coming to the mechanical and structural engineering, Cayley-Hamilton theorem simplify the calculation of powers of stiffness and damping matrices. In computer science and communication engineering, it is useful in control of robotic systems, and in civil engineering, it is useful to find the natural frequency and the mode of shapes. Thank you.